Okay, we're looking at 2.5.11. Now, for this one, the magnitude of the 12th root of 1 is going to be 1, and theta is going to be 360 degrees, because we're looking at the angle of that one right there. And so then if theta is 360 degrees, we know x equals s. And so instead of starting at whatever x is and then multiplying it by s to the 0, we're actually starting at s and then multiplying by s to the 0, which is s to the 1. So that's why I started here at s to the 1. Okay. So we have what we talked about in the last video on 2.5.9, and we were talking at the end of that video about how if we can look at if they're relatively prime, then it's a primitive element. So let's look at 1. We're looking at this one. Is 1 relatively prime to 12? Yes. So that means it's primitive. And I totally suggest watching these two videos side by side. So first watch 2.5.9, then watch 2.5.11. All right, so now 2 and 12. No, so not primitive. All right, so 3 and 12. No, are they relatively prime? No. 4 and 12. No. 5 and 12. Yes. So we get a primitive element here. And also when we go around that circle using De Moivre's theorem, we'll find that we hit all elements. We hit all 12. And also the order is 12 as well. Hopefully that makes sense. So then let's look at 6 and 12. No. 7 and 12. Yes. So that means there's a primitive element there. All right, so let's look at 8 and 12. No. 9 and 12. No. 10 and 12. No. 11 and 12. Yes. So there's a primitive. There. Primitive element. So right here. So there you go. Those are the 4 primitive elements. And yeah, there you go. They need to be relatively prime.